Swayam Prabha. Digital India. Educated India.
Point 931 meter cubed. 1.5. How are you able to manage different answers for the same question? All the data exactly same. Huh? So great, I say. Even science is not exact. We thought only, God is not exact because it can be described by anyone in any form. Okay, but science at least we thought exactly one can define. Right? Newton's law, whether you do IIT Madras or IIT Bombay or IIT Kanpur, it is same. It should not change. So, but I think here our problem, what is the thing? Correct answer is around 7 meter cubed. 7 meter cubed. Yeah. So you thought it is very large value and then you did. So you thought so like that? Okay. Yeah, check again. I think the correct answer will be around that. It is of course slightly complicated problem. It is a reversible reaction, and also it is of course the other timing and all that you have to add. I think you will get the reaction time. How much reaction time you got, by the way? Yeah, I think around 5000 seconds is the correct answer. Yeah, around 5000, 4920 seconds. Yeah, still you manage so low value. If the reaction time is right, is only reaction time plus another 1800 you have to add. 5000, around 5000 is okay. Yeah. Huh? That maybe I think when you are taking that other value slightly this way, that way. Huh? Yeah, and then you have to add that 30 minutes means 1800 seconds, or you can convert that into minutes and then add. So then divide with the total production rate, number of batches and per batch, that is all. Correct, no? How many number of batches?
That is too much, sir.
What do you mean by too much?
It's points.
Around 13 batches.
Yeah, around 13 batches.
Mass per batch.
Mass per batch.
Then it becomes up to 100 tons per day, sir. That is, answer should be 0.7. That is more logical.
No, you have again the 30 minutes going and all that, no? Yeah, so, but I think that is the one. 7 meter cube, around 7 meter cube you will get maybe 6.9, 6.8 like that. Try again. But the reaction time is right. I don't know how you have calculated other things. Okay, reaction mixture density also is given. Where do you go wrong? It is probably you would have gone wrong where you have CA naught equal to is not equal to CB naught in this case. Okay.
13 batches also I got, but the value I am getting is 0.7.
0.74. 0.74 I am getting.
I got, but anyway, others I think, others also you try. I think many people, I know only 10 people would have done. The remaining other people would be only watching. Okay, I think you also do, and then let us discuss later. Okay, so I got around 7, maybe wrong sometimes. Okay? Around 7 meters. 7 meter cube. Okay, good. Yeah, I think now come to the class. Now present class. Plug flow reactor, right? We have been discussing about the concept of plug flow reactor, and I asked you, can you write 2 concepts in CRE? Right? That is one of the that is the last question in that 0th test. The first first day when I gave that test. Okay, there was no answer. This is one of the concepts. Concept means something you imagine in your mind, and then based on that you develop all the equations, and now try to find out whether you have your original I mean assumption and the actual calculations whether both are same or not. If both are same, then your concept is right, right. So, this is one of the concepts in chemical engineering, and it is a beautiful concept, plug flow. Why it is beautiful, I will tell you a little bit later. And we told that the basic definition of plug flow is, tell.
Flat velocity.
Time spent by each and every molecule must be same. So, then automatically you should have flat velocity profile. Now, I think you have a feel what do you mean by axial mixing. Axial mixing is pushing people in the queue backward and forward, okay. Like that, even in reactors, because of the turbulence, and you should not confuse with the turbulence and mixing. The turbulence in pipe is very limited, in the sense that it is only velocity fluctuations where we take them as turbulence, whereas mixing also told that there is turbulence, but mixing is a big chaos. Mixing occurs throughout the equipment, whereas in the turbulence, when you have a pipe, and then when you are talking I am talking about pipe flow, okay, very clearly we have to distinguish that, because we have two extremes, one is mixed flow reactor, other one is plug flow reactor. So, in our plug flow reactor, when there is a pipe and then through which the flow is going, then the turbulence what we are talking is velocity fluctuations. Now, you can go and see McCabe Smith book or some other fluid mechanics book, where they nicely show only small variations in the fluctuations of the velocity. That fluctuations are not allowed now for plug flow, even that fluctuations are not allowed, right. So, that means molecules enter exactly like flat velocity profile without any fluctuations, it will move, and now the reaction depends on how far it has moved, and you know the total length we are providing for the reaction to take place. You let us imagine that you have provided 30 seconds for 99% conversion example, right. So, around 10 seconds you will be in 1/3, then the reaction, I mean the conversion will be not exactly 1/3 here, it is not linear, okay, conversion cannot be linear, I mean depending on what kind of reaction you are talking. So, that is why here you will have some conversion, then afterwards again you will have some conversion, afterwards again you will have some conversion. But when I look at the cross section, you will have the same concentration at that cross section. That is why we say we have infinite infinite mixing radially, and all of you would have assumed, you know, definitely, or I think for your gate examination also you would have prepared that infinite number of tanks giving you plug flow, okay. Really, did you understand that concept? Mathematically you can prove it, okay, but really has it gone to your blood? Once it goes to blood, only the concepts will be with you all the time, okay. What is our assumption? In the assumption itself you have that definition of infinite number of tanks giving you plug flow, just in the assumption itself, but we never go deeper into that assumption, correct, no. So, what is the assumption? At any cross section you have infinite mixing. When do you get infinite mixing? When you have one perfect mixer, okay. How many cross sections we have in this? That is all, that is why infinite number of tanks. Also, when you calculate, you know, for 90% conversion plug flow is this much, okay, sorry, for 90% conversion plug flow is okay, for 90% conversion mixed flow reactor is giving some volume, right. Now, you want to use number of tanks in series, okay. You calculate for one tank volume for 90% conversion, it will be much larger than plug flow. Then you take 2 tanks, what will happen to the volume? Decreases, okay, to some, that also we will do an example later. Then you take 3, further decreases, you take 10, it becomes very small. When you go to infinity, that will be equal, volume size will be equivalent to almost 0, where you are defining what is radial length, transverse direction, radial length, I mean that radial dimension. You see how simple it is, I do not need any mathematics for that, okay. This is a favorite topic for many examiners also to be given, prove that infinite number of tanks give you the plug flow equation. You take first order and then write some equations and then try to prove it. You do not have to prove it really, if you, of course, mathematically there are still some people who will not believe words. So that is why for them mathematics are required. So then you go for mathematical proof and say that yes, what I imagine and what I also mathematically proved, both are same. You see how simple it is to remember now, very simple to remember. Why infinite number of tanks should give you plug flow? It is in the definition itself. Normally we do not think beyond assumption of flat velocity profile. Some more things, if you a little bit you think a little bit more, then it will be radial direction mixing equal to infinity and axial direction mixing equal to 0. Okay. So, but I think I may give in the examination prove mathematically that infinite number of tanks will give you plug flow, that is different. Okay, that is mathematical examination, but the concept wise very simple to do that, because I am taking sufficient time, because the entire reaction engineering is based on only 2 reactors. Out of that, the second assumption, that mixed flow assumption is very simple for easy imagination, that is very simple, whereas this one is not that simple. Like parrot we repeat, because my teacher repeated that it must be flat velocity profile, I will also go and tell that it is flat velocity profile. Fortunately or unfortunately, if you become teacher and then you also tell the same thing, flat velocity profile. So like that, generations it goes as flat velocity profile without trying to understand what is the real concept, why this flat velocity profile should be for plug flow, because idea is that each and every particle must spend exactly same time. For that all these definitions are required, flat velocity profile and axial mixing equal to 0, radial mixing equal to infinity, all these things are required, right. And then we also have other extreme. G. E. Davis is grandfather of chemical engineering. Okay. Another his cousin was this Arthur D. Little. So that is why you have to do that. I mean, that is only your interest. I told you there is no description of real pleasure in learning. We cannot tell in words. I told you, there are few things which you cannot tell in words. Yeah. So that is why this joy of learning is totally different. I mean, you cannot express in words joy of learning. And the moment you have that kind of learning in you, you should not get arrogant, but I think you will be happy with yourself. Others may not be happy that much, but you yourself are very happy if you know many things, but that should not go to you into your head, and then you should not belittle others, they scold others and all that. Okay. But still I think that gives you, that is why, I mean, every god must be like that, but we see this lot of movies and many movies are there in Krishna, on Krishna. Okay. I told you, I am not particularly religious on anything, I do not all are equal for me, but example I am telling. So he knows what is going to happen, I mean at least in the books, what is going to happen, what has happened and what is happening. So that means he has got all the knowledge, and you can see him how he will smile also very carefully. You can see that, that smile will not be laughing like me, ha ha ha, he will never, Krishna will never, okay, because other people will laugh like that, Duryodhana may laugh like that. So like that, every time you look at him, you look at him as if he is a very pacified person, very calm. Like that, I think any gods, I mean at least we imagine gods, yeah, any gods history if you read, all of them must be like that, because all of them understood what is going to happen, all the knowledge what they have. Okay, we are only trying to draw some fraction of it, 1/1,000,000th of it, 1/1000,000th of it from that source. If you imagine, I mean if you really truly believe God, I believe nature, I think so, that is why what we are learning is all from the nature, and the entire research is only to crack nature, just to find a small thing of what is happening, how clouds are forming, big problem, big research problem, how they move, why that shapes, they are not beautiful circles or beautiful triangles or rectangles, all different kinds of shape, and you look at a cloud and then just imagine that it must be a beautiful girl, it looks like beautiful girl, or again you look at that and then say that it must be a beautiful bird, then it looks like a beautiful bird, because by the by we always say beauty with girls, we never say with boys. You know the reason? I think it is on this planet it is totally different, human beings are totally different. If you take any animal, male is very beautiful, only in humans reverse happened. Okay. No, really, see peacock for example. Male peacock is very beautiful. Lion, that male lion is really wonderful to see, that magnanimity and that kind of the moment you look at that, oh my God, lion. But if you see again female lion, you don't feel that. Every day you may be seeing, any animal which cannot see without the aid of light in the night, they will happily sleep after 6 o'clock, the moment dark comes. But that is the only time you start working. And we are also same on this planet, the life is same. Life cannot be different because all the species have come on this planet. There are some I think 90% of the species daytime sunlight only they take food, and then they don't do any job anyway. They search for the food throughout, and once they have sufficient food, then they want to propagate their own species, and then that's all. I think male female will join, and then they simply propagate their species. That's all. You are chosen on this planet only to propagate your species. If you allow the humans, I think they will really pollute very fast. Okay, so that's why I think all other restrictions are there. In China only one child, and India it may come half child or something like that out sometime, because we are crossing China. Okay, so but I think naturally they will control on their own in other species, right? I don't know whether you heard the name Aris, Rutherford Aris. Okay, has anyone read his book? You read that? I will give you a Nobel Prize if you really understand that. Okay, really I think very very complicated. He has written same Leonspiehl information in terms of mathematics. But if you understand these concepts and go to Rutherford Aris book, wonderfully you understand. But his mathematical knowledge is fantastic. I think even for conversion he uses the term xi, where for most of us we don't even know how to write this. You see, like this, that is xi. Xi is the conversion for him. We write simply xa, like this. What do you call that? Xi only, no? It's not epsilon. Epsilon is only this. Epsilon doesn't have tail.
Yeah. Zeta.
No, zeta is again different. It goes like this. They also have that capital form, and also they also have a small form. Okay. Yeah. So they have, I think this is xi. So that kind of complicated, but I think he is very stable, very good, and he writes poetry. Poetry comes when your mind is stable. Please remember that. Anyway, so coming back to that, that's why I told you, all this started because of the pleasure in learning. That you have to taste. The moment you taste yourself, you cannot come back. We will say that you have that nectar, no, amrut. Yeah, this will taste much more than amrut. This passion for knowledge, once you start enjoying the happiness of learning. Really, I am telling you, you just try that. I don't know if even one tries, I think I will be very very happy. So that is why our time is limited during our education, right? So we will have only in the school you will learn something, but you don't understand. Okay, when the university you learn also, but with understanding you have to do that. Then when that understanding comes, automatically fantastic. Really very very happy. So for that, only thing is you have to read and then try to understand. That's all. If you are not able to understand, ask friends, ask people, ask teachers, all that. And you should not feel bad that to ask anyone if you don't know something. If I don't know how to add 2 plus 2 equal to 4, that means really I don't know that. So that means why should I feel bad? I can happily go and ask. That's why each and every individual is different. My learning capacity is different. So you would have easily understood 2 plus 2 equal to 4. I would have not. But because I should not compare with you and then go and say that no, I think I can't ask because people will laugh at me and all that. You should not, because each individual is different. We will say that okay, after first class you should remember this, after second class you should remember that, after chemical engineering you should remember that, or mechanical you should remember that. These are all our own limitations what we put, but brain will not accept that. That depends on only your capacity of learning. So for that, and also one beautiful thing with brain is any time you can learn. I think even a person about to die 90 years, If he is interested in chemical engineering, he can still come and start with what is chemical engineering and all questions, and then he can learn. Brain accepts that. It is not that beyond certain time you cannot learn. So that is the beauty with brain. No, that is beauty with nature. Anytime you want to learn, you can learn. Not only we, any species. Otherwise, you would have not survived. If that learning capacity is not there, learning capacity does not mean that getting degrees. Huh? Yeah, learning capacity is trying to observe with the nature and also go along with the nature and try to escape nature if there is like for example there is a tsunami or there may be explosions or there may be what is the lava and all that comes volcanoes, yeah, all this, because all species run the moment they see lot of lightning and also thunder, right? Yeah, so that is why, I mean that is also a learning. No, I do not want to learn, I will just stay there, even if thunder comes means you will be charred, that is all. No, you will become carbon element 12 with C, yeah, anyway I do not know periodic table what is the position. Okay, anyway, so okay, I will give you one more concept here to remember, so that you will not forget what is plug flow. So definitely most of you would have done residence time distribution. Okay, so now we say that each and every particle should spend exactly same time. Okay, so now if I introduce here some color, so that I will also see how this color is spreading throughout the reactor, plug flow reactor. So what I do is I have various ways of putting this color. One way is, just imagine I have a tube, 4 inches tube, and then I take a disc of color, disc, we only remember our CD discs, I am not talking about the hard disk. Okay, a hard disk has got another meaning. Okay, CD type, very small thickness, red colored one, this is white color, this is water which is flowing, and suddenly I would like to introduce that red disc inside this, which is totally soluble. It is soluble, it is not hard disk, that is what I was telling you. Okay, so then and I know that the total time is 10 seconds. How this disc moves inside the disc? It is water is continuously flowing. By some, it is only imagine the experiment. By some imagination, I will just assume that okay, the disc suddenly entered into the cross section exactly fitting there, exactly fitting there. It is uniform cross section. Even though I have written slightly bulked here, bulk there, I think it is exactly same cross section. How does that move? Moves as
such.
What, Swami? Not able to imagine? Able to imagine, no? Because this is water flowing. Just imagine that a small thickness of that flow has become suddenly red. How does that move? Yeah, Sushmita, you are telling something. Moves like what?
As such, it moves as disco. If it's ideal, it will,
Ideal. It is ideal only what we are
it will
talking.
move as such.
How does that come out here?
As a disc.
As a disco.
Exactly as a disc.
Because
That is the reason why when you have this is equivalent to your direct delta function. Okay, that is what is called pulse input. Pulse input. Suddenly you introduce the pulse and then observe at the end how did you get this pulse, right? So even at 50% of the time, if you look at the midway, then exactly you will see that red disc, and here it comes. That is why we normally show that the pulse enters like this and then comes out, not reversed but same thing. This is what is direct delta function. This is what I also asked another question in for ideal reactors, plug flow and zero test. Yeah, plug flow and mixed flow, what is the ET? This is the concentration we are talking, but the concentration can be converted into more useful function called excitation distribution function. Okay, why useful? I think we will discuss when we come to RTD. Why that is useful? Why we should define like that? But this is simple concentration. Now pulse input, this pulse input we discussed. Now let us say that I have step input. Step input is water is entering continuously, right? The color of water we know. Then I will also have another stream of red fluid, red. Okay. So then at time t equal to 0, I will switch off this. There is a valve here and there is another valve connected. The moment I switch off this valve, another valve will open, exactly same flow, no disturbances not allowed. Disturbances not, in reality you will have not no disturbance is allowed. Then I will allow this red fluid to enter and then come out. What do you see at the end? After time equal to 10 seconds, you see only red fluid. That is step input. You know, you have the step entering here, something like this, and also coming out exactly, yeah, something like that, exactly like that. So RTD also is very easy now for imagination once you have this. But in reality, what happens? In reality, when I have this, you know, we are talking about turbulence in pipes. So that means turbulence in pipes is small fluctuations over the velocities. So then what will happen to this disc when you have small fluctuations over these velocities? Huh? Like what? How does that spread? Because you have uniform concentration in this disc, right? So it is huh?
More concentrated.
Yes.
When it will come out, it will be more
Uniformly?
No, in the center there will be more.
Yeah, it is center of what? Center of
The
the
pipe.
center of the disc.
Center of the disc. That is.
no pipe here. I think pipe it is just
Just the reactor.
Yeah. If I looked at a small, okay, I think let me draw this. You know, this is the disc I am introducing. It should be in fact infinitesimally thin, but if I write infinitesimally thin, you cannot see. So that's why I am drawing it a little bit thickness. Okay. So imagination is this one. Yeah, this is the disc which I have just entered, right? And this is uniform concentration throughout. When it is moving, there is velocity fluctuations over this, around this, right? So how does that spread? Somewhere here, how does that spread? See, there what happens is the concentrations at this point, because this side water, correct? No, when I imagine somewhere inside, here, this side water I have, this side water we have, but now it is moving with the velocity fluctuations. So from here to here when it comes, then the concentration here is less and concentration here also is less. So you will have like this concentration. No, this is concentration I am plotting. This is the concentration. Okay, this is the concentration and this is the distance. This is the thickness of the thing. Now that pulse is slightly getting widened. Yeah. So at this point it may go like this. That is what is residence time. That how you see this is the concentration only what we are talking. If I now see this is time at this end, if I see, so that means the molecules which are here, the front portion when it is moving, those things will come first and then later at the center and later at the back. So that is the disturbance what we have there. That is the spread in residence times. I also gave you some example that, you know, when you have this kind of fluctuations and if the average time is 10 seconds, some molecules may come in 8 seconds itself because of the fluctuations. I think I don't know whether I gave you this example when you are talking about that Tirupati queue. Okay, so when you are about to see the god, I think maybe you are just entering that main temple, that portion. So then when someone pushes you, you are very happy because you will just go and jump before the god. Okay, that means he is able to see at least maybe few seconds before than the person who is just in his line. Okay, he was in that line, but because of the forward backward movement someone pushed him, so he felt forward. So that is for him, that is the exit I am telling, that is why. So then that means he will come slightly earlier. So that is why the molecules here, if I have 10 seconds mean residence time, some will come in 8 seconds or 9 seconds and some will come in 11 or 12 seconds, but that is small disturbance. that is small disturbance, and in plug flow you will have only small disturbances because your velocity fluctuations are not large. If you have infinite velocity fluctuations, excellent, mixed flow reactor. Why? A molecule here is about to leave, okay, then because of infinite fluctuations you have, there may be one fluctuation which will suddenly take this one here, okay, it cannot go out anyway because continuously it is pushed all the material. So then again suddenly it may be pushed somewhere here, okay. So if you have that infinite fluctuations, that is mixing what you are telling, so then you will have throughout the reactor you have the same concentration, that is the other extreme, that is the other extreme, okay. That is all, how simple it is to remember these concepts, but entire reaction engineering is based on this. Again I am repeating that is why I am spending so much time, because you should not forget now onwards at least. That is all very simple, and the residence time distribution wise also you will have very small distributions when you have plug flow. When mixed flow comes, I will tell you how much distributions you will have there. Very small distributions only normally. That is why that distributions, to take care of these small distributions, we use what is called axial dispersion model. Axial dispersion model. Actually this is the correct model for when you assume plug flow, the correct model is axial dispersion model, because definitely there will be some dispersion, you can never avoid that, okay. You can only avoid if you are using infinite velocities. If you are putting infinite velocities, then across the entire universe you will have the length of the pipe, correct. Now velocity equal to infinity, so whatever length you put, zero time only you can provide, right. I mean exaggerating, okay. So that is why the correct model for any plug flow model is, ideal plug flow model is the correct one. Realistic model is only axial dispersion model, but we take that and then we will first derive the equations, ideal plug flow, to see what kind of equations we get and how far we can deviate from that. Unit processes by Shreve, every day you are using his book. Shreve was the person who has really pushed unit processes name after looking at unit operations name. We also should have for reactors, all chemical processes are imagined as unit process. That is why the name of the book also, beautiful book. What is that book? That is the book, straight away, like Levenspiel used chemical reaction engineering. After that Groggins used unit processes in organic synthesis, all reactions, nitration, alkylation, tell some more. Esterification, it is not organic process. Alkylation, yeah, okay, I mean all that, yeah, all that, there are so many, nitration, benzene, not benzene, alkylation, there are so many things, all those processes have been divided into unit processes, okay. And for chemical reaction engineering, who has put this name for plug flow and mixed flow, at least just guess. Someone told Levenspiel, but he is not Levenspiel. Levenspiel beautifully used all these concepts. Denby, kg, yeah, kg, not grams, kgs. Kg Denby, he is the person, I think the name is given to him, that he was the person who has given. His writings are fantastic. He is from UK, I think he was in Cambridge, yeah? Cambridge University or so, yeah, Cambridge only I think, but wonderful really. The way he writes, he won't use much mathematics, but he will tell all beautiful things about the subject in terms of words only. Conceptually he is excellent. Chemical equilibrium, name of the book. This book maybe I think 500 pages, around that, yeah. Chemical equilibrium, wonderful book. Again I think thermodynamics is most of the time abstract, and then nice concepts, nice words only we have to use. So, that is why this book is called one of the bibles for thermodynamics for chemical engineers. So, that is why Denby books, wonderful book, even if you do not understand, read it. 10 times if you understand, you will automatically 10 times if you read, automatically you will understand, but you will not have time to read 10 times, because all of us only are focusing, okay, tomorrow exam, today night preparation, over. That is the problem with all of us, no? Our education system is like that. Okay, that is chemical equilibrium is one book. Another book is chemical reactor theory and introduction, very simple introduction, that is another name, another book, chemical reactor theory. In fact, this course chemical reactor theory was named after that book. It is coming for a long time, almost 20-25 years, this course chemical reactor theory. Okay, last 30 years I think this course is there in IIT Madras, and that course is named only after that book came. Small book, you can read like a novel, not much mathematics, but wonderful explanations. Even for plug flow also, he will not mention directly time as the basic definition of plug flow, but he will give two assumptions and then say that one assumption automatically requires this condition, or the time of each and every particle is exactly same, like flat velocity profile, that is one assumption, one point he gives. So, that 1 point flat velocity profile should automatically will satisfy only when all particles are exactly spending same time. Okay.